So last class, everything was clear. Maybe I'll again come to SVM and all. Oh, LD and all, sorry. Now I'll come up with the perceptron learning. So any idea about perceptron learning? My screen is visible, everything is fine now. Any idea about perceptron learning? Yes, come on. What do you think? You have seen the lectures and all. What do you think? What is perceptron? Anyone? Come on, let's try. Okay. Let me first give you the idea behind that. Gaurav, yes, you want to say something? You have unmuted.
Oh no, ma'am. I actually, it's almost like SVM without the border. That's what I was gonna say.
Okay. Still, we have to do that SVM part also. Okay. Any other thing which you want to share, like what's perceptron learning? Any other idea? Come on. Can I say that
For linear stable data sets, perceptron works, and for a particular threshold, if it crosses the threshold, then the perceptron will fire.
there is a lot of disturbance? I'm unable to hear you. Can you again unmute and speak, or you can write in the chat, because there's a lot of disturbance from your end.
Okay.
So what is perceptron learning? Basically, suppose, first of all, it's a classifier, linear classifier, which means it is basically separating the class. I have +1, I have -1. I have two classes, which it is separating. Linear classifier it is, which means it will draw a line, it will separate. Fine. Now, suppose this is the line which it draws. What does this line mean? I can say this is suppose one class, the points which are positive, they are lying on the one part of the line, and which are the circles plus they are lying on the one point of the line, which are circles that are lying on the other part of the line. What do you mean by that? Plus or circles? Like, what do you think? This is a hyperplane. Like, this is basically they are separating a hyperplane. They're basically separating the classes. So we are drawing a line to separate the class. That is what a classifier does. Is it clear? No, Bhavna, I'm not solving assignment 7 of week 7 now. We are basically lagging behind. We are on perceptron learning. Today, we are actually doing week 4. That is perceptron learning and SVM part, basically. And we'll solve the MCQs as well of perceptron learning and SVM. Okay, let's continue. So what I'm trying to say, it's basically separating the classes. So this hyperplane, hyperplane means this dimensional plane, whatever we are doing, the 2D plane or in higher dimension, whatever, it is defined as, I'll write, this is simple line equation, mx plus c, that is what I'm writing. This is basically a hyperplane. What we are saying is, this is, we are basically having a linear classifier, which is classifying the points. And this is we can define it like this. Now, if it is greater than 0, we are saying it is classified as +1. If it is less than 0, so it is classified as -1. What if it is equal to 0? Can someone tell me? Yes, we have discussed earlier also in LD and all. Simple words.
The
Yes.
class 3.
No, not class 3. Yashwant has written. It's on hyperplane. Basically, it's on this margin. It's on the hyperplane. Gaurav, what I'm saying is we have two classes. If the class is positive, then it is +1. If the class, this line is basically above, so it's +1. If it's below, then it's -1. Now, we have only two classes. We don't have three classes. Actually, last time also you told me the same when we were doing LD. It's class 3. So when it's 0, it's basically, it's on hyperplane. It's on margin itself. Fine?
Yes, ma'am. Yes.
So let's understand this geometry of this hyperplane. I'm trying to make it as simple as possible. As you were saying, it's going complex. Trying to give you as much as intuition as possible. If still I'm lagging behind, if still something is missing, tell me. Okay, now what I'm saying is, for 2 points, if I have some 2 points, x1 and x2 on the line, what I'm saying now, it's on line. In on line, which means it is equal to 0. Which means x1 is equal to 0 and x2 is also equal to 0. Fine? How it's equal to 0? Fine? Clear? Because what we are saying, if it's above, then it's greater than 0. If it's below, then it's less than 0. And if it is equal to 0, what we are saying, it's on the line. That is what we do, na? Mx plus c, it is equal to 0, which means this is a line equation. This is equal to 0. Now, let's subtract both of them. Both of them means 1 and 2. We got what does this mean? Can someone tell me? Can someone give me the intuition of this? B transpose x1 minus x2 is equal to 0.
Either
Yes.
one of them either one of them is 0, or this is it's invertible.
Can I say it's perpendicular?
Okay,
Beta is
yes.
perpendicular. A dot B is equal to 0. How it's perpendicular? Now I want to ask you how it's perpendicular. Let's try. I'm saying that if I'm writing this, professor also told it's perpendicular. Why it's perpendicular? Now don't say me, I'm asking why and all, just for you guys. Why it's perpendicular? Yes, come on, let's try. Nothing I have done, no maths. Only what I'm trying to say, if it's online, it's equal to 0, subtracting them, it's perpendicular. Now I'm asking you why it's perpendicular. What does A dot B is equal to 0 means? What is cos 90? 0.
1,
That's
ma'am.
cos 90 is
1, ma'am.
yes.
1, ma'am.
Cos 90 is 0. Cos 0 is 1. Anyone else? Remember, cos 90 is 0. That's what I'm saying here. You are maybe you are mismatching. Sin 90 is 1, sin 0 is 0, cos 0 is 0, and cos 90 is 0. Cos 0 is 1 and cos 90 is 0. Fine? Clear? So what I'm saying is, when A dot B is equal to 0, which means it is perpendicular. Because AB cos theta and cos theta, which means theta will be 90 degree. That is why they are 0. So that's why we are saying that they are basically normal to the line. Beta is basically perpendicular. Any confusion till now? Now, the MCQ can be about this as well. What does this mean? Beta transpose, is it perpendicular? Is it this? Is it this? So what should be the answer? It is perpendicular. Why it's perpendicular? A dot B is equal to 0, which means AB cos theta is equal to 0, which means theta is equal to 90 degree. Fine? Come on, class, fine?
Yes, ma'am.
Let's take it as beta star. Unit vector. What I'm doing is, let us take it as a beta star, which is a unit vector, and do the normalization. Or leave it. Not go again that complex. You have to do that. So what I'm doing is nothing, just saying that there is a variable called beta star. When I am normalizing it, dividing it by the norm of beta, I'm getting this beta star. Just I am writing it, doing the normalization. So now what I'm saying is how much distance from point to hyperplane. Fine till now? Okay, I'll tell you, Bhavna, what point we have to remember for the exam point of view. Don't worry. So what we are saying here is, I have a distance x. What I'm saying is, what is the distance of x point to the hyperplane? That is what I'm saying. Please mute yourself.
Shouldn't everything anyways be perpendicular? If you draw a
Yes.
straight line between the point and any line, it will be it will be perpendicular only, right?
Yes. It's perpendicular only. Now, I'm just writing a mathematical equation like what's the distance. Let's try to understand it. What is B star? B star is nothing, just the normalization vector of the beta only. This is trans. Because matrix, when it will multiply it, norm will be equal only. 1 minute, let me write, then I'll explain you. Please mute yourself if you don't have any doubt. Now, what I'm trying to say is, okay, till now, what I have said that, okay, it's perpendicular. The other point which I have said, let's normalize it. And when I have done the normalization, it's like this. I'll come to the point, Bhavna. What can be the questions here? I'll come to that point. Now, the other point is, what is the distance from the point to the hyperplane? What I'm saying is, let x naught, it will be, let x naught is in the hyperplane, which means it is in the margin, lying on the margin. Now, what is the distance of any point x to that hyperplane? That's what I'm writing. The distance thing. Now, the star I'm replacing with whatever we were having, just because we are multiplying it and these are matrices. So I have to have the transpose thing. and norm will be the same after the transpose itself. Now opening the bracket, we know that x naught is in the hyperplane, and if x naught is in the hyperplane, if it's on the line itself, we know that it is equal to 0. That's what I'm writing here. Fine till now? Fine? When I'll open these brackets,
Yes.
or here I can write beta transpose x naught is equal to minus beta naught, and minus beta naught transpose x naught is equal to beta naught, I can say. So this beta transpose x plus beta naught, we got it. Fine. And this was also good. What if I and what is this? This is nothing but fx. And what if I differentiate with respect to beta, this thing? What I'll get?
Differentiate by beta naught, then you'll get beta t by x, right?
If I differentiate with respect to beta.
And with respect to
Beta. Okay, wait a second. With respect to x, I think. With respect to x.
only the
Beta term, I'll say.
beta term, yes.
This, can I say this is f dash of x with respect to x? Can I say that? Let's again continue. Maybe I'm going if someone is having confusion, what I have done. Can someone elaborate in very short term what I have done so that others can get to know? So that I also can get to know whether you are getting the concept or not. Bhavna, I'll come to your question. Don't worry. Please, can you tell me in the chat whosoever have got the concept and whosoever has not got the concept so that I should know? What we are saying that perceptron is a linear classifier dividing the points. Does x1 and x2 understood? Does x1 and x2 are the points on hyperplane? Yes, exactly. That's why they're equal to 0. What I have told you that whenever the points are on the hyperplane, let it be, then they'll be equal to 0. If it's positive, then if it's greater than 0, this fx will be classified as +1, which means it lies on at the class +1. And if it's negative, it lies at the -1. That's how we are differentiating, that if it's above the line or if it's below the line. And if it's on the line, which means y is equal to mx plus c is equal to 0, which means that it is on the line. So when I'm saying that it's on the line, which means it is equal to 0. Okay, Yashwant? Now, what I'm trying to say, if I'll subtract these both, two of them, then what I'm getting is this thing. And if I'm getting this thing, which means that beta is basically perpendicular to this x1, x2. Beta is perpendicular to this. How I'm getting it? Because a dot b is equal to 0. And I know that a dot b is equal to 0, which means they are perpendicular because AB cos theta, theta is 90 degrees. Now, what I did is, I took the beta thing, I did a beta star, I just normalized the beta by dividing it by the norm beta. This is just the notation thing, okay? This is beta star thing. Now, what I'm saying, what is the distance of any x, not x1, x2, any x from x0, which is lying on the hyperplane? Okay, that I'm asking. Then I'm replacing this beta star with this term, and then I'm opening the brackets. And one more thing, I know that x0 is in the hyperplane, and if x0 is in the hyperplane, I know that beta transpose x0 plus beta naught will be, this fx will be 0 because it is on the hyperplane. I got this beta transpose x0 is equal to minus beta. When I open these brackets, I got beta transpose x minus beta transpose x0. And I know that beta transpose x0 is nothing but beta naught. This was minus, so it got plus. And this is nothing but fx. And when I'll differentiate with respect to x, I'll get the beta. This is nothing but f dash of. So basically normal.
So essentially, over here, ma'am, you're trying to tell us how beta is beta, which is the weight, is
Mm-hmm.
figured out by the program. And
Mm-hmm.
if we differentiate, we are finding out the loss function. That is what the difference between beta actual and beta phi.
No, actually, if you'll see that, I'm not figuring out what is beta. It's just a different distance I'm saying, nothing else. I'll come to those all the terms. What I'm saying here is the distance. Beta transpose, if the what is the distance from x to x naught, which is lying on the hyperplane. That is what I'm saying.
But then why are we differentiating them? Because I thought differentiating is for the local minimum and loss function.
Yeah, nothing differentiation. Here, if you see, just I'm giving a notation. What I'm saying is here it was written beta, just another notation. If I'm writing like this, nothing else. So if in exam, you know that the distance, this is this. And in exam, not in exam for your benefit also, if it comes like this, so you should know just another notation, nothing else. It's fx and it's nothing but f dash. It's another notation, nothing else. It's
Okay.
not any, uh, like, you know, as you are saying that if we are finding out beta, you are correct that when we used to find out beta, we used to differentiate. It's not that differentiation. It's just the another notation. Now, fine.
Uh, just if you go one step back, you said we differentiate only by x, right? That's it. That which this is.
Mhm.
We only
Mhm.
differentiate by x, right? So shouldn't we get beta by beta, like shouldn't we get the normalization equation anyways? Why are we taking?
Differentiation of this, not this part. This is fx. This part is fx. I'm differentiating this part.
Okay, okay. Um,
So it's nothing, just another notation.
okay, understood.
What about others? Okay, I think there was a question now. Now coming to question. There was a question in the assignment. The context of in the context of perceptron learning, what does fx over f? Now the same question. What does fx over f dash of x represent? Can I say now distance to hyperplane, sine distance to hyperplane? That is what I was saying. This was the distance to hyperplane. How it was distance to hyperplane? That is what we have calculated. X minus x naught. What is there is a point and there is a point on the hyperplane. What is the distance between them? So that is the normal answer. Fine. Now, if you have solved this, if you have done this, you can easily get to know, okay, this was a distance. You can remember from the class, okay, this was a distance. So you can take in the MCQs that this is the distance. So if you have done these maths part, the MCQs are like nothing to you guys. That is what I am expecting. Is it fine? What else
Yes,
MCQs?
ma'am.
What else MCQs can be after this completion of perceptron only? Before jumping to the other topic, I'll first cover the MCQs, then I'll jump to the other topic. Fine, na? Okay. Now, what is the idea? This was just, I was saying that how much is the distance of any point to the hyperplane? That was, I was telling, like, point to the hyperplane, what's the distance? How can we basically measure it? This is how we can measure it. And it was actually asked in the assignment also. Now, coming to the intuition, one more thing. This is a learning classifier. We got the so we have other learning classifiers as well. So how it is basically different from the other learning classifiers. So what is, as you always get confused, why we have to do this and what is the difference between other algorithms and this one? Let's try to understand it. So can someone tell me, what do you think? As maybe I'm expecting that you have attended the classes, lectures, and you have completed the assignments also. Ma'am, please, after completing each concept, you can take one by one assignment questions and explain so that we can. Yes, exactly, Bhavna. That's what I'm trying to do. Like, this was a question which was asked in MCQs only, this part. That's why I went through this question. And I'll also take the questions of the assignments side by side only. And I'll also give you more MCQ problems as well. There was one question only for the perceptron. That's what I'm telling you. Other questions, extra questions also, I'll teach you after, like I'll give you after this. So what is the perceptron algorithm? Let's try to understand the intuition behind it. So I have a decision boundary, you know that there was a decision boundary, and whatever points was above it, they were referring to the one class, and whatever the points were below it, they were referring to the other class. Okay. So now there can be points which are misclassified also. Like suppose here we have all pluses. There can be some minus also, which are called misclassified points. So what is the major goal in the perceptron learning, which can come again in MCQ, Bhavna? Any point that are misclassified. Misclassifier, can someone again tell me what is misclassifier? Come on.
Originally, it should be class 2, but it is coming in the model output as class 1.
Exactly. So it's class 2 or 1, it's coming in -1, or if it should be -1, it's coming in the +1 or 2 or 1, as you have said. So what I'm saying is that if the point is misclassified, it should be as close as possible to the decision boundary. So what is the intuition? If it's on the correct side, I'm happy with it. What does perceptron learning says? If it's on the like correct side, okay, fine, I'm happy. But if it's misclassified, if a +1 is misclassified, +1 is misclassified as -1, we push the hyperplane towards it. Or I'll say, I want the decision boundary as close as it. If -1 is misclassified as +1, so that should also be the same. So I want, it's okay if they are misclassified also, but to fix it, move the hyperplane by updating the weights. That's what I'm trying to say. If they are on right side, their correct side, happy. If they are at wrong side, they should be close to the hyperplane. I'll write it. So this is the line equation. What I'm saying is, suppose x transpose beta plus beta naught is less than 0, then it's -1, suppose. Label as -1. If x transpose beta plus beta naught is greater than 0, it's labeled as +1. These are the classes. This is the actual one. Now what I'm saying is, if these are y, the output class, y is equal to +1, and if it's misclassified, I'm saying the output is +1. If it's misclassified, which means it is incorrect, the class is incorrect, can I say now what it will be, greater than 0 or less than 0 if it's misclassified?
Less than
Less
0.
than 0.
Less. Now this can also be the MCQ, which can come with you. So here, fine. Now, what is the perceptron criteria? I'll write. Then you should tell me what I'm trying to say. Maybe I'll do it, make it simpler. Is it misclassified or correctly classified? If I'm writing via into X transpose beta plus beta naught.
It's misclassified.
How? Okay, you're correct. Then
Well, it
misclassified.
is misclassified because the left hand side is positive, but it's less than 0.
Left hand side is positive. Okay, what you're saying is why it's always positive?
Distance between 2 points can't be negative.
Somewhat
So,
correct.
so the x, the beta not x, that is definitely positive.
Somewhat correct only. So what? Maybe I'll. Since you're also fine, misclassified. You're also fine, Gaurav. Misclassified. So what I'm trying to say, if suppose y is equal to +1, so this should also be positive because if it's +1, it should be positive. So this will positive into positive should be positive. So it should be greater than 0. What I mean to say, if yi, 1 minute, I'll explain again. X transpose beta plus beta naught is greater than 0. If it's classified correctly, it should be +1. So it is positive, the answer should be positive. In the other way around, if it's negative, this is also negative, -1, that's what we are saying. And negative into negative should be positive. So in both ways, if the class is +1 also, if the class is -1 also, when we'll multiply this and this by I, it should be positive only. Fine. Any doubt what I'm saying?
Yes, ma'am.
So if it's negative, which means that either the case is that this is negative and I am misclassifying it as +1, or either this is positive, I'm misclassifying it -1. So it means that if it's negative, the multiplication of them is negative, then it is obviously misclassified. Correct? So what is this? So minus is just that this is negative. What I'm trying to say, these are basically set of all I belongs to M. These are all set of misclassified points. So here in Perceptron, I am concerned about the set of misclassified points here. So because why I'm concerned about misclassified points, because I don't want that it should be far away if they are there. First of all, I want that this M should be empty. But I want that there shouldn't be any misclassified point. If there is a misclassified point, then it should be near to the decision boundary. What I'm saying, if you are wrong, then don't be that much wrong. You shouldn't be that much wrong, very far away from the opposite side. That's what I'm trying to say. And first objective is I want that this M, the set of this I belongs to M means whatever I, like sum of I belongs to M means the sum of the misclassified points. Why misclassified? Minus means that this is negative. And if it's negative, it is obviously misclassified. We have seen it cannot be correctly classified. Now, again, Bhavna, the question can be, as you asked me, what is this? Minus yi. Or if I'm writing plus yi. These are classified points or misclassified points. It cannot be misclassified. They are always correctly classified points. Similarly, they are always misclassified points. What is the why do we want M? What does this mean? I want this M empty. Can someone tell me?
It means we don't want any misclassified points at all in the set.
My main objective is I want this M empty. I don't want any misclassified point. And one more thing, if data is linearly separable means, can you tell me what do you mean by I'm saying again and again linearly separable? What do you mean by that?
We can draw an hyperplane which separates the classes.
So I can, there is a, like I can draw a hyperplane, I can draw a decision boundary which can basically separate the data. Data is basically linearly separable, that which can like divide the classes between them. And one more thing, in Perceptron, talking about the convergence thing, again, this can be MCQ question. Again, keep in mind, if I'll come how, if data is linearly separable, Perceptron will eventually find separating hyperplane. So there will be a separating hyperplane in finite steps, I'll say. If not, then it will keep on updating in and again, and its weight will keep on oscillating. If it's not linearly separable. Can you tell me first of all, what is gradient descent before jumping like going out of context, because this is needed much.
Ma'am,
What,
I have a question, ma'am. You said that the goal is M should be empty. Uh,
I was expecting this. Yes. I know what you are doing. Yes, come on.
okay, no, ma'am. According to the lecturer, it was the goal should be to minimize D.
According to the lecture, the goal should be minimized.
Minimize D. So D into beta naught minus beta. Yes, beta 1 is equal to minus. So over here, the lecturer had said that the goal was to minimize D, not to completely remove all the misclassified points.
The goal is to minimize D. What do you mean by minimize D?
Which means to minimize the distance.
D means B beta naught. This I have written. What do you mean by this? I'll come. You are saying earlier also I have mentioned any point here I have mentioned that I want that it should be, the idea is I have written here. I want that it should be as close. I myself has written, I have written, and then now say any point that I misclassified is as close as possible. You're saying this, na?
That was also, yes.
Now you're saying at one point I'm saying that any point which is misclassified, which means this misclassified, is close to decision boundary.
No, it is possible that any data set might have a wrong answers, wrong data.
That is different thing. That is different noise thing. But now I am saying my goal is to have the MMP.
Okay. Yes.
And that's what you are saying, that I'm having a conflict. I'll tell you. So
Not a
basically,
conflict. In an ideal world, both of them should be same.
same. Ideal one, both of them is same. Exactly. So one thing is like I'm saying that it should be minimum this misclassified points, and one point I'm saying that it should be empty. Actually, both of them makes the same statement. But I'll come to that point also. If I was saying that it should be as close as to decision boundary, and now I'm saying it shouldn't be there. That's what you are asking. I'll come to that. And now I'm also saying that if it's linear separable, it should be empty only. Like it should actually converge. We should find a separating hyperplane. That's what I'm saying. I'll come to this. First of all, can you tell me what is GD and what is SGD, gradient descent, and what is stochastic gradient descent? This is the core machine learning, like you should know. I'll give you a very simple example. Can you tell me? I'll have water. 1 minute. Yes, come on.
This one is stochastic gradient descent, another is just gradient descent.
What's the difference?
Just forgot.
Okay. Shamunji, you were only asking me na last time that maths. Is it fine now? Today's lecture, the intuition based as well as
Yes.
one is derivative, another is derivative of derivative. Oh, Mayank, you are here. Okay. Can you tell me a simple layman language? I'll not go to maths.
Ma'am, it's somewhat related to the bargaining kind of these things. Like suppose I'm not okay to pay 100 rupees, but I'll pay 98 rupees, something like that. GD.
Okay. And SGD?
It's cumulative is altogether.
Stochastic.
I'm not sure.
Stochastic means
When considering all the points, you will come to some conclusion, not only considering only one like that.
Okay. Let me tell you 1 minute, please. A simple layman example I'll give you. Let's try to understand gradient descent as well as stochastic gradient descent so that you shouldn't forget whenever someone asks. I'll give you a simple layman example out of this computer science. So imagine you are blindfolded. Standing on the mountain. Basically, these gradient descent, stochastic gradient descent, I'm basically, they are basically the steps I have to take in the direction of gradient. Maybe I'll write first this layman language, then I'll come to that gradient and everything. Okay. Imagine you're blindfolded, standing on the mountain, and want to know which direction is downhill. I'll ask all the villagers, average all of their opinions. That is gradient descent. I'll first write the SGD, then you'll come to know. Here, now what I'm saying, I'm blindfolded. I don't know where is downhill. I'm asking all the villagers that where is downhill, and then averaging their points, averaging their no maths, averaging their opinion. That okay, he said this, he said this, he said this. So let's take them. SGD. I'm asking one villager at a time. Then I'm basically going down, then asking the another, basically updating it quickly. Ask one villager at one date, and then update it quickly, update the step. Update means at that point only I'll go down, and then I'll again ask the another villager, then I'll go down. So here what is happening is, in gradient descent, I'll have all the data points. I'll gather all the data points, I'll average them, and I'll update the weights. Here, SGD, I'm taking one data point only and going with that into like whatever it is saying, going it with that. SGD basically, as you can see that it's taking lesser time. Here, I'm waiting for all, so it's taking more time. But in SGD, we can see that as I'm asking only from one villager, it can be sometimes noisy as well. You got somewhat intuition behind the gradient descent as well as SGD? Come on.
Yes, ma'am.
What about others?
Yes.
Yes, ma'am.
So,
I know what
Will
you're
it affect
saying.
the precision?
I know what you're saying, ma'am, but I think it would be easier for people to understand if you draw it as a, a ulta U that's going on.
I'll come to now technical terms. What I'm saying is, Gradient descent. Update the weights. First of all, gradient. You know gradient, that differentiation and all. Let's first take the differentiation. I'll again come to gradient descent. And as Gaurav said, that I'll again come to that gradient descent and SGD. Don't worry. First, I'll tell you what is how. Let's first have the gradient of this beta. What's the gradient of this with respect to beta? Come on.
With respect to beta, it's just xi into yi.
Minus yi into xi.
Yes.
With respect to beta naught. Minus yi. Summation, obviously, it will be there. So as soon as I am moving, now one more thing. Why we are doing this? What we did in, can someone tell me when we were, as you were only saying me, Gaurav, like ma'am, we have done differentiation and calculated that beta and all. Like why we are doing this gradient descent or SGD first step? You got some intuition behind SGD and GD, but why we are doing it?
We are trying to reduce the loss. So what gradient descent is like, it is you have a loss and you want to reduce it, and the way you reduce it is by going down the by reducing yi into xi, which is technically as good as going downhill.
Exactly. But reducing the loss, but we were not doing gradient descent or SGD. Now why we are doing? You are exactly saying the same thing, a correct thing, that okay, we are reducing the loss. Yes, Ketan.
We are doing SGD when we want to make it easier to compute.
Okay. Now the reason is here actually whenever I am moving this beta, the set changes. So I have to recompute this gradient. This misclassified points actually change whenever I am moving it. Do you got the point?
Understood.
So when it is changing, that's why I have to actually do this. When the misclassified points was like these points were same in the earlier cases, linear classification and all, but because we were not dealing with this misclassification points, here the set is basically changing. Here, that's why I have to go with GD version or SGD version. So GD is basically what I'm doing. I'm computing the gradient of all misclassified points. Now I'll write in the technical words. Maybe you'll get it, what I was trying to give the intuition, and maybe you can relate it with that. Compute gradient over all misclassified points. Sum them before updating. Obviously, it's slower, as we have discussed. It's smooth, I can say, without noise, but I can say it's expensive. SGD version, which we are using in Perceptron learning. I'm updating the weights immediately. So as I told you, I'm asking from all the villages where is downhill, where I have to reduce the loss. So that's why I have to reduce this. So I have to go, I have to take the gradient. I have to basically go the downhill. I have to reduce it. That's what is the main intuition behind it. Look at the mistakes, adjust it. That's what is the intuition behind it. Now, here I was taking all the misclassified points earlier, which is obviously slower. Here, whenever I'm taking one misclassified point at a time, I'm updating the weights accordingly. for each misclassified. It's actually faster. Some I'll say noise can be there, but it works well. So SGD is basically applied in Perceptron. As soon as you make one mistake, you immediately correct yourself. That's what SGD means. I'm making mistake, I'm correcting it. GD means I look at all the mistakes you made today, then adjust your rule. Fine. Now, Bhavna, if MCQ is between GD and SGD, can you do it? Now, what is the rule? How we update it? So this is the gradient part, xi, yi. This is basically of beta naught, the gradient part. This is beta. This is basically the update rule when we are doing this. Basically, we are doing this again and again. These steps we are doing it. This is update rule of SGD. What is this delta, anyone? Can someone first explain this equation again?
That is delta. I thought that was.
Okay, no, that's not gradient. That's, what is this? This. In some books, there is lambda, something else. Like, what's this? What does
This,
ma'am.
this is
Rho, ma'am.
this is like learning rate 0.1 maybe.
Exactly. It's a learning rule. Now, can you explain this equation first so that I should know everyone is getting? Any one of you? I want that everyone should participate in the class. Again, I am saying yes, nay. Everyone should participate. Yes.
Ma'am,
No.
basically we are updating the step,
Exactly. So what we are
the
doing?
values of beta and beta naught.
Yes, exactly. So we are basically updating the step. That is how we are doing so. What is learning rate? As he has told us, Gaurav has told us that this is learning rate. Can you tell what is learning rate? Okay. Come on. Let's try. How you are taking each step, basically, that's a learning rate. Okay. First of all, giving the intuition of this again and giving the intuition behind this equation. This is a gradient descent, or this is, I'll say, SCD step. How it is working? Can someone explain me? We are working on the misclassified points. We differentiated it. This is the gradient thing that we got by differentiating it. And this is basically the update rule of this GD. That's what we are doing it. Like whatever we have, this beta plus the learning rate into the gradient of this. That was this.
So if it is, ma'am, if it is gradient descent, we'll use the upper one. If it's stochastic, we'll use the lower one. Is that what it means?
I didn't get you. Lower one or upper
So,
one?
ma'am, we've been discussing whether we'll use only gradient descent or stochastic gradient descent. If we
Yes.
use only gradient descent, then we'll get summation of xi yi updated.
Yes,
But if we use only stochastic, we'll only get yi updated, right? So
because we are taking one misclassified point at a time. Exactly, you are correct.
so technically beta. So when we are writing it in brackets, we are trying to divide into an upper and lower, right? Either upper one or lower one, we are going to update.
No, we are updating both of them, beta as well as beta naught. We are updating.
So are we doing both of them simultaneously, stochastic and gradient?
It's just I'm basically no SGD I'm doing SGD. If you're doing GD, then you will sum the gradients of all misclassified points, then update it only once. Here, as you told me that why I'm not writing sum, as you have only told me, what I'm doing is I'm taking one misclassified point, misclassified data point, observing them. Then I'm basically making the update. I'm basically updating it. I'm trying to correct it.
Okay, so this is stochastic gradient.
Stochastic gradient.
Okay.
So I'm computing the gradient, moving the weights opposite to it so that I should correct it. I'm making the update. This is the update rule. Now, learning rate, how I am moving it. I have to move it downhill. I have to basically decrease it. I have to basically correct the misclassified points. How I am moving it, that's basically how the steps which I'm moving. Usually we take it very small. The steps, why the steps should be very small? Come on. These are the steps, the learning rate. How much efficient we are classifying? Efficiently we are classifying. I'll come to your answer. I'll come to your question.
To minimize error and noise. The smaller the steps, the error might be less.
Yes, exactly, Sneh. You are exactly actually correct. So minimize, because as we have done that SGD, I'm taking one update at a time. I'm taking from one misclassified points. I'm not asking from all of them, so there can be a noise also. So I should have taken it slow, but as per the setting, if delta is equal to 1, that actually works. That is actually fine here also. But usually we take it in perceptron learning. We have observed in the experiments delta is equal to +1. Do work fine. So fine. And coming to your question, Yashwant. Wait a second. I have written somewhere. If data is linearly separable, perceptron will find separating hyperplane in finite steps, which means it is actually very efficient when the data is linearly separable, when there is a line which can divide between the two classes. So it is actually 100%, or not actually, I say 100% because noise can be there. It is actually near to 100% linearly correct, efficient, I'll say, if the condition is data is linearly separable. So if data is linearly separable, again, I'll say then perceptron learning algo converge to some solution. We will find the hyper. Bhavna, another MCQ. So there can be many solutions as well. Many solutions in this way. So I can have a line here, I can have a line here, I can have a line here. These all are hyperplanes, and these are all are classifying it correctly. So there can be many of the solutions here. How? It depends on the starting point from where I'm starting, how I'm updating it, because this starting point, when I'm updating, I take it randomly. So it depends on that. So, and if data is not linearly separable, then I'll say M will not be empty. Now, one more thing, as Gaurav was pointing out that, ma'am, you have written this thing. Why you have written this thing? Any point that I misclassified, it should be as close as possible. That I am trying to do in my GD. Whenever I'm misclassifying it, I'm taking it as close to decision boundary. And then I'm trying to, the SGD and GD point. Every time I'm going to downhill, which means every time I'm trying to eliminate it by making it close to the by drawing the hyperplane close to it, so that at last the main goal is it should be negligible. This misclassified main goal is actually it should be negligible, and if they are linearly separable, it will be basically it will be separable only. And one more thing, that if it is not linearly separable, then it may enter into loop and M will not be empty if they are not linearly separable. Fine. Is perceptron learning fine to you guys?
Yes, ma'am.
So it depends on the starting point, and if it's linearly separable, that which solution I'm getting at the end, I will basically converge to any of the solution. Is there any MCQ? Maybe, huh? So there was a question. Now again, coming to the MCQ of the assignment, for any given linearly separable, for any initialization, okay, maybe SVM is there, so I'll not touch it. And okay, and for any linearly, question number 6 of assignment 4, you guys can check. For any given linearly separable data, for any initialization, both SVM and perceptron will converge to the same solution. We haven't done SVM, but I know that for perceptron, there can be many solutions. There is not only a single solution, because it depends on the starting point. It depends on which misclassified point I am, okay, which misclassified point I am basically my first SGD, because one misclassified point I'll take and then I'll converge. So from where I am starting, it depends on that. I can have many hyperplanes here. So it's not the answer that it will converge to the same solution. So it is false. Any doubt now? Yes, Saurabh?
So, ma'am, you're saying because there'll be always multiple solutions, it is unlikely they'll always converge to the same solution,
Same solution.
even for a linearly separable. Okay.
It will not convert to, as I'm saying that there are multiple hyperplanes. So it will not convert to same solution. There are multiple solutions for that. So the answer for the assignment was false because of this. One minute. I'll open the MCQs. Wait a second. Any doubt? Yes, class, any doubt?
No, ma'am, but thank you. Taking a class this way actually helps because otherwise MCQ was difficult for me. I understood most of the questions. Now I am understanding.
Just a minute. What about others?
Yes, ma'am, it is helpful.
So let's start the MCQs on perceptron. Basically, is primarily used for. Now these are very basic MCQs. Come on.
Linear classification.
Exactly. And now I'll tell you guys, please write in the chat. Everyone, can you repeat 6th question again? That last question, ma'am. Okay. Yashwant, the 6th question, I'll repeat it again. Can you check the 6th? Have you opened the week 4 assignment? So the 6th question of week 4 assignment was for any given linear separable data. So what they're saying, the data is linear separable for any initialization. Both SVM and perceptron will converge to the same solution. We are doing perceptron. I know that perceptron doesn't converge to the same solution, as there are many solutions. I can have many hyperplanes. It depends on the starting point. So this is false, that perceptron will converge to the same solution. Fine, Yashwant. Should we proceed? Maybe I'll open in the. Okay. From next time, I'll open in good notes only. For now on, please adjust here only. Okay. Please write the answers in the chat so that everyone can answer. Don't speak so that everyone can get some time for answering it. Question 1, please write in the chat. Write A, B, C, D. Snake. And everyone else also write A, B, C, D. Exactly. It's a very simple question. Write 1A, 1B, 2A, 2B so that when I'm going to second question also, exactly the way Dr. JM has written. Now coming to the second question, what is the answer of second? The perceptron learns a separating hyperplane. Exactly. The decision boundary. Maybe I'll
Just
write.
one question, ma'am. Polynomial surface and hyperplane can be mixed up, right? Because technically a polynomial surface is all three.
But now in perceptron learning, okay, you're saying that polynomial surface, yes, they can be.
Okay, ma'am, no problem. Hyperplane is because you said hyperplane so many times. Hyperplane is correct.
Yes. So the decision function, maybe I'll write here. Wait a second. I'll write the question here only. The decision function of, I'll write the options here because that's confusing. The decision function of perceptron is maybe I should bring more tough questions. These are very easy one. The decision function. This is question third. Exactly. Everyone is correct. 3A. Again, I'll write it here to be more clear. Question 4th. So it's like a point lies on separating hyperplane. So I'll not write again. It should be less than 0. It should be equal to 0 or it should be. So what is the answer? I want everyone should be correct. These are. Exactly. So it should be equal to 0. Now, which vector is normal to separating hyperplane? It's beta naught, it's y. Basically, it's x, beta naught, y. While copying, actually, it got. I'll write here, maybe. I'll write here only. Maybe I'll come up with the other document. Okay, which vector is normal to those perpendicular to hyperplane? X, beta naught, or y? Maybe I'll write the equation also next time. What about others? What we have done right now? I'll write the equation also maybe next time. Exactly, Sneh. You are correct. Beta. Question 6. Distance of x from hyperplane. Beta transpose x. Yes, come on. What is the answer of 6th? Come on, everyone. Someone is saying B, someone is saying C. Someone is A also. So can whosoever has given A, B, C, can someone tell me the justification behind that? Okay. Sorry, 6C. No, it's B only, Gaurav. You were correct earlier. Okay, I'll tell you. We have done this normalization. After that, you know that. So we were saying that it's like beta star transpose X minus X naught. We were saying that only, na? Beta star. And then we were saying that beta is equal to this. And then we have actually done this also. Maybe I'll tell you here only. Sorry. Okay. Some confusion is there. It's fine. Minus beta transpose X naught. And the other was that X naught is lying on the hyperplane. So I was saying beta transpose X naught plus beta naught is equal to 0. So beta transpose X naught is equal to beta naught. So beta transpose X plus beta naught. So I can replace this by this and okay, not understanding this. I'll come to it again. Now there is a real confusion. Okay, Sneh has understood it. Okay, there is a real confusion. Distance of X, as you have got, first of all, whosoever is given A, obviously where is plus beta naught, that is missing there. Whosoever is given C, where is again beta naught normalization, it's not there. Now how it's like B, how the answer is B, let's try to understand. I have told you that beta transpose, that's why maths is important, so that we can actually do multiple things and we can try to understand there was a point X to X naught which is on hyperplanes beta star. So this is the distance we have done. Now I know that beta star is basically beta over beta normal. This also I know. Fine. Now I know that X naught is on hyperplane. And if it is on hyperplane, fx is equal to 0, which means that beta transpose X naught plus beta naught is equal to 0. So I can write it as beta naught is equal to minus beta transpose X naught. One thing. Now, when I open the brackets, beta transpose X minus beta transpose X naught. What is minus beta transpose X naught? Beta naught only. So beta transpose X minus plus beta naught. That is what the B option is. Now, everyone has answered C to me. I think Nidhi or Gola, very less of you have answered B, 1, 2 or 3 students only. Is it fine now? Why others are not answering? I want everyone should participate. Is it fine? Please give me thumbs up if you have got why it's B, why it's not C or A. Please give me thumbs up. Only one thumbs up yet. What about? Okay. Fine. Let's go to the next question. Maybe I can go to 7th. If fx is greater than 0, ignore this multiple times. The perceptron classifies the point as +1, -1, misclassified or on decision boundary. Now it's simple only. You have to write 7A, 7B, 7C like this. if fx is greater than 0. Correct. Okay. What about others? Only Gaurav has responded. What about others? Come on. Now you got it. Why maths is important? As you were saying me, the from sixth question. I hope so. Okay. Perceptron update occurs only when point is correctly classified, point is misclassified, gradient is 0, and or hyperplane is optimal. Again, a tricky question. Not that much. Exactly. What about others? I want everyone should participate. Yes, exactly. So why we are dealing with the misclassified points only, as I have repeated many times in the class. So that's why perceptron update occurs only when the points are misclassified. Ninth, I'll write. The weight update rule for perceptron is can you tell me the answer now? Come on. Sneh, please write 9 or yes, come on. Everyone should answer. Only 2 or 3 of you have answered. 20 students in the class. Exactly. Everyone is correct. Sneh, it's not C, it's D. I'll tell you why D. So now, obviously your C is correct. Now, what D is saying, you have to read the MCQs very carefully. You shouldn't do like she has done, Sneh has done by like quickly seeing that, okay, it's eta yixi, so it's correct. So it's correct also. This is also correct if this learning rate is equal to 1. And this D option says both A and C depending on the learning rate. So the answer is D. Jyoti, the answer is D. Basically, that's what plus sign is there. But this learning rate is missing. But if the learning rate is +1, so this A is also correct. So that's why the answer is D. Both A and C depending on the learning rate. Fine. Going to question 10. Please see this 10th, 11th, 12th. Okay. Please see this these questions. Wait a second. Sorry. I'll come in a minute. I'll have water. Yes, class. Okay. So you have written the answers. Let's see. So 10th question, perceptron converges if and only if data is linearly separable, data is linearly inseparable, margin is 0, gradient descent is used. So 10th, let's see. So everyone has correctly answered 10th A if data is linearly separable. Okay, correct. Perceptron algorithm is equivalent to linear regression, a single layer neural network with a step activation, logistic regression classifier, multi-layer perceptron. Okay, maybe we haven't done this. Okay, leave this 11th question. I'll come to this neural network and everything, then I'll tell you. With loss function is associated with the perceptron. Okay, I haven't taught you that also. Okay, leave this 11th and 12th question. I'll come to that afterwards. Leave this 11th, 12th. 10th is fine. Till 10th, everything is fine. Did these MCQs help you? Fine. Maybe I was having some other MCQs also in the last class. Maybe. Okay. Okay, I will come. 1 minute. That I'll come up with SVM when I will teach. Now after SVM, we'll solve more MCQs. I think more MCQs I have of perceptron. So clear the perceptron learning with MCQs. I think this perceptron learning, everyone is cleared with that, this topic. Let's proceed now. Problem with perceptron learning. So if it's linearly separable, sometimes the convergence is slow as we're using STD, but eventually we'll converge. If it's non-linearly separable, basically if it's linearly separable, or in other words, I can say that the speed of the convergence, it will depend on the starting point from where we are starting. And we'll take it randomly as we don't know which misclassified point we'll pick up first. It depends on starting point, but we are finding an optimal solution there. I'll not say optimal, we are finding a solution there. There are many solutions. There is not only a unique solution. These things we have learned. It is depending on starting. If it's non-linearly separable, we did that it will go into a cycle, it will oscillate. It's like we can't find a separating hyperplane. That can be the cases. So these are the problems with the perceptron learning. The convergence speed will depend on which starting point we are starting. So can someone tell me, as Yashwant is asking, what do starting point mean there? Come on. I want you guys should answer. Basically, starting point, we pick up initial weight, which are random. What is weight now? This beta. These are basically random. Usually we started with 0, taking it with 0, and we are updating it. Actually, we have to find out the optimal beta naught, and we are updating it. That's what we are doing. This initial beta basically, oh sorry, not B1, this initial beta, this is basically random in nature. What we do, we start with beta and beta naught. I'll write it in layman language. For each training point xy, if they are correctly classified, I'll do nothing. That's what we learned. But if they are incorrectly classified, which means that incorrectly classified, we know that, as I know, these are incorrectly classified. So if they are incorrectly classified, I'd update them. This is the gradient, this is the step, and this beta, basically, this is the initial beta, which is the initial weight. This beta basically is random. This is any, whatever we want, 0 we want, anything random we want, we'll start from that. That is basically the initial point, what I'm referring to. Fine. Yashwant, is it clear? What is starting point? Not x1, x2, but the starting point is this beta or beta. These weights. Usually when we do the programming also, we take it initially randomly, or we usually when we are programming, we take it as 0 here. And then we keep on updating this beta and beta naught so that we should get to the optimal one, optimal weights. So optimal weights in the sense we should get a separating hyperplane. So here I want optimal separating hyperplane. There in SVMs, I should first tell you support vector machine. Here what we want, I want optimal separating hyperplane. Now what is the difference between SVM and Perceptron? Can someone tell me by one statement only? Can someone try?
There's thickness to SVM, but perceptron is just one line. If perceptron is a line and hyperplane is a plane, literally.
You are actually correct, but what I meant is like what I have written optimal separating hyperplane. I mean, here I want only one separating hyperplane, one like which should be optimal in nature. Optimal means which should be the best one. There I was saying now that we have many solutions of hyperplane. I know you are correct, Gaurav. As you said, there is a line here, there is a margin. I know all those stuff. I was saying you there can be many lines, there can be many hyperplane. We can converge to some solution, but we'll eventually converge. It can be any solution. But what here we are saying is we are converging to optimal solution, which is the best solution. We want a best hyperplane. Correct? Now, the question in the MCQs was, when you'll see the answer, when you'll see the question number 6, again, I'll go to the question number 6. It was, for any linearly separable data for any initialization, both SVM and Perceptron will converge to the same solution. SVM will converge to a single solution. Perceptron can converge to many solution. So they'll not converge to same solution as Perceptron can converge to many, but SVM will converge to an optimal solution. A single hyperplane, best hyperplane we are trying to find in SVM. What is best? I'll try to tell you. Fine. Now, maximize our objective in SVM here is, what is this optimal hyperplane? Maximize distance of closest point to hyperplane. Or I'll first draw the figure so that you can get the intuition. Sorry, should have either plus or either cross. So this is basically the margin. Fun. This is a decision bound. Find decision boundary, we know. What is decision boundary? Which is basically separating the classes, that we know. Now, I have some margin as well. What is this margin? I have a margin on upper side, I have a margin on lower side. Now, what I'm saying is, can someone tell me what I have written here, the intuition behind that? Maximize the distance of closest point to hyperplane. Come on, try. What do I mean by that?
The x that is close to the middle line, you want to maximize the distance, and the same thing on the other side where 0 is the max.
Exactly. So I want that the distance from the both the classes should be max. But how much they should be moved? Other question comes, how much? I should move farther away. I got it. This should be farther away from this. As you told me, this should be farther away from the closest point. But how much? Another question comes. I have a closest point to this. I have a closest point to this. They should be far away from this. But how much? Now, how much? The answer is from both classes, same distance from the hyperplane. Whatever the distance is between this closest point should be the distance between this closest point. And this point touching here, this point touching here, we are drawing a line and margin. So margin, what is it? Distance to the closest point, distance from the closest point to the hyperplane. Fine. Come on, class. Come on.
These margins will always be parallel, right? That's
Fine, na? Okay. Margin, I want it far away from the margin. I want it far away from the hyperplane. I draw a margin which is like point touching the closest point, the line point to the point, the line to the closest point, touching the closest point from both the ends. And this margin, can I say this margin should be maximized? This is the thickness of the slab from both of the sides. This distance should be basically the same, and it should be maximized. That is what I was saying here. Maximize the distance of the closest point to hyperplane. Why maximize the distance from closest point to hyperplane? I want that these points should be far away from this. They should be actually very well classified, correctly classified. They shouldn't be mixed with each other. There shouldn't be here cross or here 0, x or here 0. What I want, this m should be maximized, this margin should be maximized. Any doubt here? I'll come. Any doubt till this point? Give me thumbs up if you have understood the intuition behind this SVM thing. Come on. Give thumbs up. Only 2 thumbs ups yet. Whosoever has not given thumbs up, ask me doubt, like why you haven't is there any doubt you have understood? If you haven't understood, tell me so that I can try it again. Yes. Okay, write in the chat if you have understood. If you have any doubt, write in the chat or unmute yourself. What max m means? Okay, can someone help me? Like, can someone tell what is max m? I have explained now. Only if you have understood, you have given me thumbs up. Explain to Bhavna what's max m.
Basically, we are trying to maximize the margin That is like we will maximize the distance of the point from both sides of the decision boundary and they should be same.
Exactly, correct only. So Bhavna, what she's trying to say, it's correct only. What we like she said is, like these are the points of one class, these are the points of both class. We want that they should move away. Yashwant has also written. Um, okay, Dr. Jayamuda, next class I'll do this. Okay. By moving away from each class, what will come means you repeat it again, ma'am? Okay. Okay. By moving away from each class, I'll again draw the figure and I'll again give you the intuition. This is one class. This is another class. This is the hyper or decision point. I want that this class point, these points should be away from these points. That is my main objective. That should be the main objective of linear classifier. And they should be as much as far as possible. So how can I make it far? What I did is, one more thing. I saw which one is the closest point to the hyperplane. So this is the closest point to the hyperplane. I draw a line touching this point. This is the closest point to the hyperplane. I draw a line touching this point, as Gaurav said, parallel to the decision. And I told that this is margin. And I want that this should be far away from this, which means that this margin, this is the margin, this is the thickness. Margin means this is the thickness of the slab. This should be as large as possible. If they should be as far as this, and they are basically, one more condition is there, they are equal. And if I want this closest point to be as far as possible, then this thickness should be as large as possible. Do I make sense, Yashwant and Bhavna? Now
Yes,
you
ma'am.
and Bhavna, is it clear? So that's what our main objective is in SVM. Because I want optimal hyperplane, I want that they should be as far as possible. So maxim such that can someone explain me this? We know yi, this was the fx point, this was yi. What now? Earlier I was writing either it's positive, either it's negative. Now why I'm writing it's greater than equal to m? Come on, let's try why it's greater than equal to m. Oh, sorry, why is maybe it got deleted. Yes. Come on.
The margin point that should be long as much, ma'am.
Yes. Someone else? He's correct only, yes. Come on.
Ma'am, as we move away from the decision boundary, when we move in the positive side, the yi and xi both will be positive, and when we move in the negative side,
That
they both will be negative.
That was perception.
And their
That's
product will be positive.
That is
And
perception.
then,
Now, why
okay.
you are correct only, positive, negative, everything you are saying correct. What I'm saying, earlier we were saying it's greater than 1, it's like less than 1. If it's greater than 1, which means it's classified. But what I'm saying, it's greater than m. What do you mean by this? What I'm saying is that now it should be greater than m. What I'm saying is not only earlier what I was saying, yi into xi transpose beta plus beta naught should be greater than 0. That's what I was saying in perceptron, as you told me. If they have to be correctly classified. You told me now only, fine. Now I'm saying it is greater than equal to m. What I'm trying to say, not only they should be correctly classified, but they should be at least m margin away. That is what they should be m margin away. What is left side of equation? Can someone explain what is left side of equation? We have already done now before. Distance of the point to the hyperplane. That's what. Distance from the hyperplane, distance from the decision boundary. That's what it's written here. And if I'll multiply it by m, we were in the perceptron learning saying that if it's positive, it means it's correctly classified. Now what I'm saying, if it's greater than m, which means that point must not only be on the correct side, but at least they should be this much margin away. It shouldn't lie here. It should be this much away, this m margin away. Fine? Fine, everyone? Bhavna, have you got it, or I should explain it again?
Ma'am, I have just one question, ma'am. Let's say if the perceptron had given us the correct hyperplane, wouldn't that also have anyways been further from the margins anyways again?
I'll tell you. So, good question. So, this can be hyperplane in perceptron, or this can be hyperplane. Is it m margin away? This can be hyperplane, this can be hyperplane. That's why perceptron was having many hyperplanes. Now what we are saying is, in SVM, it should be both, the distance should be same from the both ends, and it should be m margin away means, like, as I told you, in perceptron, it's like, is it m, oh sorry, is it m margin away, this one? It is away, but it's not that much. Like, we can have many hyperplanes. Now here what we are trying to say is, I want these should be far away, these should be far away, and they should be equally far away, and they should be as much as far away as possible. And I want an optimal one hyperplane. Do you got the intuition, or I should explain again?
No, I understood.
So that's what this is the yi xi transpose beta plus beta naught. As I told you, it should be m. It should be this much away from the margin. It should be at least this much m distance away. Every data point should be at least m distance away. That's what I mean. Now, normalization. Why we normalize? A question come. Why we normalize? Earlier also, sorry, I should write them. Why we normalize? You should have asked me earlier also.
I'm to fit it within the graph.
Can I say it shouldn't go as large as possible to have some bound here? I should have this normalization factor. So we force, I'll say, for specific kind of scaling so that basically it shouldn't be as scaled as much as possible. So some normalization is there. So that's what I'm trying here. That's why I'm dividing here with the norm of beta so that it shouldn't go as large as possible, as large as it want. Because if it's greater than m, which means it can go as large as m. So that's why I'm dividing it by beta norm and normalization factor. So if I can shift it, this beta naught to the right hand side. Correct? Correct till now? Now, I arbitrarily set beta is equal to 1 by m. Why I am doing? Can someone tell me why I am doing this? I'll try to give the intuition as much as possible to you. So if I double this point, like if I double it, this will also double. So just to make it easier, so the margin, I'll say to make it easier, or so that it shouldn't be arbitrarily. If I'm scaling this will also be scaled so that and it will constraint will still be satisfied, so that it shouldn't be the case. Like that's why I'm taking norm of beta is equal to 1 by m. You got the intuition or not? Not understanding about normalization. Okay, can someone tell what is why normalization again? Then I'll come to this point. Come on, I've explained you. Come on, come on. Come on. What is normalization? Why we are taking the normalization? Yes, Medha, Sneh, Yashwant, Sachin. Yes, come on. Any one of you? Why normalization? So that it shouldn't go as large as possible. It shouldn't normalization. We do it so that the value shouldn't be optimization. No, actually, why normalization we are doing that the value shouldn't go as maybe. I'll come with the example. If I'll not do normalization, then what will happen? Maybe wait a second. So the equation is, and I'll tell you. So what if I don't do normalization? Is there any change? Any one of you? What happened? Why anyone is not answering? You're not getting the point.
No, ma'am.
What about others? Why this denominator is divided by beta? And why this beta here, I'm setting it to 1 by m. I'll leave up to you. I have given some intuition now. I leave up to you. Do some research, find out why I'm dividing it by norm beta, why I am setting norm beta is equal to 1 by m. This is I'm leaving up to you. In the next class, maybe we'll discuss this. Till now, okay, before this point, everything is clear, like why we were doing this is just a math part, why we are doing, what is the intuition behind SVM and all. Is this clear? Yes, come on, class.
Yes, ma'am.
What about others? So next class, I'll not tell you. Like you should tell me why divide by norm beta, why 1 by n is there, beta norm 1 by
Is it because because we want to maximize the left part, we want to it would be better to minimize the right part?
that will come afterwards. That maximize, minimize, that will come afterwards. What she's asking, why we are doing normalization and why beta is equal to 1 by m. Beta is equal to 1 by m. Maybe I'll give the intuition again that if you'll like increase this, this will also increase. So this constraint will always satisfy that scaling factor will basically, I want a constraint that it shouldn't be like increasing this, this will also increase. And there should be a constraint there, they should be bounded at some point. That's why I am doing this. Maybe I know you might not be getting my words. Maybe I'll come up with the example. When is the next class? Next Tuesday. Again, many things are left. I thought that SVM and all will be completed. Okay, we'll complete the SVM and start with ANN in the next class. I'll try my best as much as possible I can do. So how was today's class?
And today's class was good, ma'am. I have a doubt from the problem set from week 4. Would you be help me with question number 5? Not the problem set, but the general problem set from the website.
Okay, consider polynomial kernel. That one.
Yes.
Okay. Consider polynomial kernel of degree d operating on p-dimensional input vectors. What is the dimension of feature space induced by this kernel? P plus d polynomial kernel. Maybe we haven't done it till now. In the next class, I'll touch this polynomial kernel, that basis expansion and everything. Then we can, or maybe you can mail me that.
Sure, ma'am. Yes, ma'am.
We'll basically, maybe you can mail me, or if you want it urgently.
No,
Or
we don't want to. I don't want to urgently, ma'am. I do want to understand it though. So
actually, it's like there are different kernels. We'll discuss that linear, like polynomial kernel, Gaussian kernel, and sigmoid kernel, and everything. So in that formula base, that's like simple only. When I do this, we'll get this. Like maybe in the next class we'll discuss that here.
yes, ma'am. That will be fine.
Okay, fine class. Hope so. Ma'am, hands-on for using scientific calculator online for examination. Okay, next class I'll do that. Every Tuesday class is there. Yes, every Tuesday class is there. Same time, 6 to 8 p.m. And most of the time class is extended also, but today I'm in hurry, so sorry for that. And I leave this question up to you. I tried though, but still, I know that you haven't got, and many of you have not got the intuition behind. Maybe I'll come up with the toy example. If I'm not doing that norm beta, if I'm not equating norm beta is equal to 1 by m, then what will happen? Fine? Fine, class?
Hello, ma'am.
Yes.
Ma'am, can I say what I have understand about that normalized beta?
Yes, exactly. You are like sure.
Here we want to keep the two classes as much as possible. So
Exactly.
we can also go out of boundary by it is greater than margin. So we want to stop that boundary. We have normalized the beta. Yes, ma'am.
Yes. Out of boundary means you are saying inside or outside? Like,
It means like it is greater than means we can go up to infinite also. No?
exactly. That is what is the main.
So we
Exactly.
want to stop it. We have done the normalized one.
Don't want that it should be scaled to infinite term. That's why normalization is important. As you have said it very correctly. Yes, I will send the notes PDF. I don't have previous question paper. I'm teaching this ML for, I have taught RL and computer networks and probability. I'm teaching the ML for the first time. I don't get the question papers usually. So I don't have notes PDF. I'll upload on the drive. I have written the drive. The drive link is on the YouTube channel. Maybe, okay. Yes, I think in one of the comment of the first YouTube video, it's there. I will upload this video. I forgot to upload. I'm sorry for that. The last video lecture, I'll upload it now only. This one, maybe it will take time for preparing the recording. So most probably tonight or tomorrow morning, I'll upload. We'll get question using PyTorch. Okay, maybe in the next coming lectures, we'll check like where you upload. I upload on the drive. Can someone send her the drive link? Yes. Thank you, Yashwant. Thank you, Gaurav, for the compliment. Thank you. And Yashwant has sent you everyone the drive link, and this is the YouTube channel name. If you want to see the recording of today's lecture and others as well. Okay. Thank you, class. Hope so. Today's class was fine. I tried to cover the inclusion as well as the maths part, so that and the MCQs. Any further feedback?
No, ma'am. It is okay to continue like this.
Thank you, class.